All right, so this is the second video for the second half of the Desmos activity. This is really the more important part. It's good to be able to switch between degrees and radians, like we talked about in the first 14 slides. But you'll have a tool called the unit circle that you can always use to refer back to. The more important part is understanding sine and cosine and tangent as functions. So you've seen this before in Algebra 3-4, but we all know kind of what happened last year. So I'm going to basically go back to the beginning and just sort of talk about sine, cosine, and tangent and how we can think about them as a function. So really similar to when we did logarithms, we thought first of them as an operation. It undoes an exponent. And then we thought about what's the function of a logarithm and what does the graph look like. So then you start thinking about, well, what are these numbers that I'm plugging in mean? And what is the shape of the answers that I'm getting? So when we think about sine and cosine and tangent as an operation, they tell us something about angles and side lengths, right? Remember SOHCAHTOA. That's saying if I plug in an angle, I can calculate a side length. And that's the same idea, but now we're going to take it as a concept, as a function. So what happens as we plug in lots of different angles? What is the shape of the different answers that we're getting? Okay. So I want to just look here. I'm not going to give it away, but I want you to notice with the different colors here, what colors are matching up with each other. These are the sine values. So as we watch the point rotate around the circle, you can see that every point creates a triangle. Sometimes the triangle is on the bottom half, sometimes the triangle is on the top half. And notice the green part and the red part and think about which part is tracking with each other. As I pause it at a certain point, this kind of reveals the answer. I'm not going to completely say it, but it sort of reveals the answer here. And I really want you to think back to what we know about sine. We know that sine is the opposite divided by the hypotenuse. Remember that our angle theta is the central angle. So this side is the opposite, and this side is the hypotenuse. One thing I want you to think about is, how big is this circle? I've called it the unit circle before. You can also look at some of the measurements around there to think about how big the circle is. And if you know how big the circle is, then you automatically know one of the sides of the triangle. And you can set up your ratio. Sine is equal to the opposite divided by the hypotenuse. I hope this allows you to see why we have the relationship between the green points, the green sides, the red sides, those different things. So I'm going to clear my screen here, move on. Again, I'm not trying to give away answers here. I'm just giving you something to think about while you're working through these slides. You'll need to go back through and spend some time on each of these slides yourself. So here you're going to reflect on what do you notice about the different points. Now, when we look at the sine graph, you'll notice it keeps repeating and repeating and repeating. And the reason that it continues to repeat and repeat and repeat is because you can continue to spin around and around a circle. There's no reason to stop at 360 degrees. You can keep going for 2 circles, so that's 720. Keep going for 2 circles, or 3 circles, that's 1080. You can spin as many times as you want. And so what you're seeing is you're continuing to spin. You're going to the top of the circle, down to the bottom of the circle, back home. Top, bottom. We could continue forever. Oh, I got kicked out there. So, but why doesn't it go to 360 degrees? I want you to connect back to the first part of the activity. Remember that in the first part of the activity, we talked about radians, and it took just over 6 radians to make a full circle. In fact, it takes exactly 2 pi radians to make a full circle, because that's spinning an entire circumference. And so what you'll notice is that every 2 pi, we create a full circle. Top of the circle, middle of the circle, bottom of the circle, back home. Okay? It's just like pedaling a bicycle. Top, middle, bottom, back. Okay? And if you zoom Here you can see that all we're doing is just spinning around the circle, measuring the height. Every 2 pi, we create a full circle. And that word, that 2 pi distance there, where you create a full circle, is called a period. So don't be afraid of the word period. It just means the length of a full rotation. And I just want to also zoom out because it is kind of nice to see it just continue to spin forever. The animation only does one period, but you could really continue this graph for as many rotations as you want. Okay, moving along. You'll have to go back and think about those slides and put them in your own words. Now look at cosine. Notice something different is happening. We're no longer talking about the sine value. We're talking about the cosine value. I'll pause it like I did before. Go back to drawing. Here we have our angle theta. Remember, the cosine of a theta is equal to the adjacent side divided by the hypotenuse. So think back again. What do we know about the circle? How big is the circle? What is the radius of the circle? And what does that tell you about the triangle? So when I label my sides, the adjacent side is this one, the hypotenuse is this one. How does that connect what we used to know about cosine to our new idea of cosine as a function? And then you're going to repeat a lot of those reflection questions that you did with sine, but now you're going to be looking at cosine. So almost done. There's just one more thing I wanted to show you towards the end here. You're going to go through and reflect on cosine just like you did with sine. Very similar. They look almost identical. And then there's this really kind of weird thing. This is a little bit of a mind bender at the end here. This is tangent. I want you to think about why there are those gaps and think about what vocab word that we were just working with. We worked with it in exponential functions. We worked with it in logarithmic functions. What vocab word are we seeing here? And the difference is, instead of seeing only one of this thing, we saw only one of it when we had exponential functions. We saw only one of it when we had logarithmic functions. Now we're seeing lots and lots and lots of these things here. And why is that showing up here? So that's it for today. Spend some time going back through these slides and reflecting and putting your observations into your own words. Thanks.